Okay. Does anyone have any questions beside 10.2, question 5, and question 8? What section is that, Linda?
I have a quick question. Is
Mm.
it possible for you to keep 10.3 open?
We don't have 10.3. 10.2 is the last one.
Or 10.2, is it possible to keep that open
Open for,
one more night?
it's due tonight. I don't know what you're asking for.
Is it possible to keep it open and have it due tomorrow night?
You have to email me, Tasha.
Okay.
That you have to email me. Yep. All right. So I'm not gonna spend a lot of time here. So we're gonna talk about 10.2 here. Yes. Do email me if you need anything about extension, because I'm not extending everyone's. So 10.2 question 1. So how this is, so the technology is given us by the slope is 140 and the y-intercept is 351. So which one should we use? Anyone know which regression line is the correct one? Is that A, B, C, or D?
C.
C is
D.
wrong.
D.
So it's D. Yes, D in this case. Make sure you have your y hats and the x. Make sure you know this. So when you guys write this in your finals, make sure your y is hat, but your x is just a normal x. The slope 140 is always next to what? Next to the x or by itself here? Where should I put 140?
X is next to the X.
Yep, next to the x. And then the negative 351 is your y-intercept. So this is how you write this. So Linda, what's the question with this one? This is not tough.
Oh, sorry.
And then what is y hat represent? Y hat is always means predicted. So it's always is a predicted value in this case. Okay.
I didn't understand the like the y hat and the x, which one to choose.
It's always y hat equals to x. None of this is correct.
Okay.
It's always y hat equals to a plus bx.
Okay, thank you.
It's always that form. It's not other forms, not the rest. The rest is wrong. Now this question 4 and question 5. Again, I don't have time to go through. If I have time, I will go through it. But I think I might have time to go through this because this is very important. Question 4 and question 5 are very similar. Where they give you the statistics, means they give you the mean for the x, the mean for the y, they give you the correlation, they give you the p-value, they give you the regression. And Linda, look at the regression here.
Yes.
It's y hat and x. So there's no, it's not, the other 3 that you just saw just now.
Oh, okay.
It's always like that for this case, okay? So you need to find what is the, you need to do a best prediction in this case where x equals to 4. So a lot of students, they just simply plug 4 inside this equation and then use your calculator to find out what is your y hat. Your answer might be right, might be wrong. The reason why is because you have to go through the 3 conditions. Does anyone remember what are the 3 conditions we're talking about? This is very important. This is in your, not this, but the 3 conditions will be in your finals.
The straight line.
Yep. So your scatter plot shows, will give you a straight line. We call it linearity. What's the next condition?
P-value is less than or equal to alpha.
Very good. P-value less than or equals to alpha. And last one?
No extrapolation.
Very good, Cecilia. Yep, these are the 3 conditions. If you fulfill these 3 conditions, then you plug x into the equation. This is called a good model. And what happens if it's a bad model? That means
Use
one
the
of this
mean.
condition doesn't match.
You have to go to
You have to use the mean of X.
Mean of Y.
Oh, I'm sorry, mean of Y, yes.
Yeah, mean of Y. The good thing is you do not need to use StatCrunch to do it because they will provide you the mean of Y here. So let's now, since this question did not provide us any data, because usually they give us a data that you put in your StatCrunch and do the scatter plot. So we just assume that this is good. So usually in the test, I will tell you that assume the scatter plot shows linearity in this case. So you do not need to check that condition. So next we need to find if your p-value is less than alpha. Now p-value is 0.067 and alpha in this case is 0.1. So yeah, so p-value is actually less than alpha in this case, right? Because this number is less than alpha, so this is good. And lastly, no extrapolation. How do we check no extrapolation? Is you look at the x value that you need to plug in. Now that x value given here is 4. This is what is given us. And you just compare it with your x bar. Don't forget x bar is your average or your mean for your x, which is 6.3. So my question is 4 and 6.3, are they close to each other, close by?
No.
Maybe
No.
a little bit.
Or, oh, okay.
Do you guys know where's 4 and 6.3 at, right?
Yeah.
This
So
is from
it's-
0 to 10, because usually when you rate people, this is talking about rating females. So you go from 0 to 10, 1 to 10,
Oh,
sorry.
yeah.
This is 1 to 10, sorry, 1 to 10. And the mean is 6.3, and the x in this case is 4. So are they close?
Yes.
They are close, yes. Because again, this is from 1 to 10, so you only can go 1 to 10. So since they are close, this is close. Usually for those students who are asking for how do you know it's close or not, you just take this mean and you double it. So so it should be around, so if you take 6.3 and you double it, you'll be like 12.6 and it'll be like 0. So if you try to predict anything in between this value, then it's no extrapolation. But if you try to predict something above or below this value, then this is called extrapolation. So since 4 is in this, so there is no extrapolation. Since everything here is checked, it's a good model. And what happens to good model is you just need to plug 4 into this equation. So your answer will be y hat is equals to 8.09 minus 0.323 times 4. You guys know how to use your calculator to do this one, right?
Yes.
This is pretty much, your calculator work. 0.323 with the negative times 4. I always do that first. And then because orders of operation, and then add with 8.09. So your answer in this case is in one decimal place, 6.8. The next question is also asking for the same thing. So we just need to go through the 3 condition again. Since this is it doesn't give us a data, so again we just say that the first condition matches in this case. Okay. Then guys, I don't have really time to go through so many questions. Teresa, you might need to stay back after class and we have to go through it, because the main thing today is the main course is finals review. So I'm just gonna go through this quick. So just stay back after class and I will go over that with you. So the first one is check. The second one, you look at the p-value. Since this p-value is 0, and the alpha in this case is 0.01, so this is also checked. And now if you look at the range for extrapolation in this case, The range in this case is actually goes from 132 to 194. And the mean is given us by 167.3. And you try to predict 153. That's what you try to predict here. 153, which is somewhere here. Is this extrapolation in this case?
No.
So in
No.
this case, this again, because it's in the range of the data, so this is not an extrapolation. So what you need to do here is plug 153 inside X, like what I just did just now, and you will get your answer. Now, what happens if one of these does not meet? Then your answer will be 81.54. Okay. If one of these conditions you did not meet, then your answer will be Y bar. Okay, so but this case is not Y bar. This case you have to plug 153 over here. So what you need to do is 1.04 times 153, and then you subtract from 105. So it's 54.12. Next is question 8. Question 8, you actually has to use StatCrunch to do this, and you have to for this question you have to use your coordinates. So does anyone know how to put this in your coordinates?
You just have to manually put it in.
So so your first variable is X and the second variable is Y, right? So can someone tell me what is this coordinate is? What's your X and Y value?
17.
17. So you just put 17. And then the one above it is 18. And then 19. And this is for the first first column here. Then you go on to the next one. So this is 27. And then 28. And then 29. And then the last one is 37, 38, and 39. And don't forget, you still have one more down here. That's 10 points, the last point. And this is 7-1. Rachel, are you here? Rachel?
Yeah, thank
Yep.
you.
And then you just go to stat, go to regression, simple linear, and then do your X and Y.
Okay.
And then you hit compute. And again, this one that you see here is your regression equation. Put it right there. So that is your answer here is 10.0 something. How's that one out? So this is how you put it into your StatCrunch. Make sure you put them in coordinates. 10.065. And what's the slope in this case? Negative 1.105. So you do need to put a negative sign here. Negative 1.105. And then the question says that what is the regression if you remove 7-1? So if you remove this 7-1 here, what is the regression equation? So you just need to go to your data and you remove 7-1. And then you repeat, you go add it, and then you just kind of repeat the same thing because this time your last point is no longer here. Your equation will change to 8, just 8, because it's the 0x you can ignore. So then the question is asking is, choose the correct description with this. So does this 0.71 significantly impact or they are the same?
Significantly impact.
So it's a big change. So yep. So that's why your answer is A. Okay, so this is, yeah, this point is called an influential point, so it is significantly impact in this case. And I will go through 11 quick here, Teresa. Again, because this is already there, so we will be importing to StatCrunch. That's the quickest way to do it. So what's the question here, Teresa? So they want you to do the equation.
Yeah, I got this part. Yeah. It was the, hold on, I'm opening mine.
So again, Lambert, always the first one is your X and the second one is your Y. Same thing in your finals. If you doesn't know which one is X and Y, always the first one is X, second one is a Y. So this is your equation here. So 16.618. And then your slope, my slope is negative 0.003. Oops, maybe, oh, forget one more zero.
It's
20, right?
Oh, six. You
it's
need
a six decimal
Oh, 3. Oh my goodness.
for
Okay,
the
the end rate,
coefficient.
round the constant, this is a constant, into 3 decimals, that's correct, but they want this in 6 decimals, the slope. Yeah, you read the question. 0.00 1, 2, 3, 4, 5, 6. So 2866, because 2 is too small to round, so it's 2866. Ian, read the question. 2866. Same thing, you want to make prediction here. So what you need to do is you have to go through these 3 conditions. The first thing is the scatter plot. Since we got data, so we can check on your scatter plot. Your scatter plot is just the next page. So you just go on to the next page. A pretty straight line, nice, linear line here. So the first rule here, check. Don't forget in your test, you do need to do this checking condition because it is worth a lot of points in this case. Next is your p-value. So in order for me to see my p-value, the p-value is this. You can look at this number or this number. They are the same. Make sure the 0.022. Make sure the one that is the same one. What is my alpha in this case?
Yeah, there's no alpha given. I mean, I kind of assumed, but
yep. If there is no alpha given, this is something I want to tell everyone here. So if a question does not provide us alpha, then we will default it as 5%. So everything in chapter 10, if they don't give you alpha, you default it as 5%, always. Same thing when you guys do your research and everything. If they don't give it to you, then you just use 5% in this case. This is a very common. So since this p-value is what, less than or greater than alpha in this case?
less than.
Less than, so that means that this condition is met. So the next thing we need to figure out is what number we need to plug in. 475, right? This is a number we plug in, it's 475. So what you need to do is you go back to your, this 475 inside this range.
Yes.
Yeah, somewhere around here. So that means there is no extrapolation. So since we did fulfill all 3 of these conditions, so what you do is you just need to plug in 475 into this equation. So your answer in this case will be 16.618 minus 0.02, all the decimals, the 6 decimals. Yeah, use all the 6 decimals and then plug in the 475 in there. So you cannot round this because the question really asks you to do it in that form. So 0.002866 negative times with 475, that is your X, and then you have to add 16.618. And that is your answer. 100 how many decimal place it needs? They only need 1 decimal place. So it's 15.3 in this case. Is a prediction worthwhile? Let me see. I didn't read the question here. Common sense, there should not be much relation between two variables. This is talking about lemon imports and crash fatality rate. There might be a, yeah, lemon imports. Since there could be out, there's no outliers here. Okay, this is not an out, because how do we know it's not outlier? Is because of your graph. Look at all these points are pretty nice, so that's why there's no outlier. So it's not B. That's not B. Since all the requirements to find the equation are met, the prediction is worthwhile. I think it's going to be this one. The sample size is small. The prediction. Now, don't forget the requirements for this doesn't say anything about small sample size. So the requirement says that these are the requirements. Don't forget, these are the requirements. They didn't say that sample size is small. So I'm thinking about C in this case. Is lemon imports and crash fatality rate, they have any relationship? So either
I
A
have
or
a question.
Mm-hmm.
Because, okay, so how do we use the data to determine that? Or should we just use common sense?
You have to use common sense, yes.
Okay.
I think your answer is A, because your lemon imports has nothing to do with death rate for crash. You know what I'm saying? I think your answer in this case is A. Yeah. The reason why is because this, you have to use common sense to see that in this case, because this two has nothing related.
Mm-hmm.
Yep. If he's talking about drinking and DUI and fatality, yes, then that is a common that's relationship between the two. I think this one is nothing. So yes, to answer your question in this case, you have to use your common sense. Mm-hmm.
Okay, I have a question. In the test, are we going to be dealing with common sense questions?
No. It's going to be stopped right over. So you don't get the last part. The only thing I will ask you for this is I will ask you for the regression equation. I will ask you for this thing, but I won't ask you the last part.
Thanks so much,
Okay,
David.
good.
Mm-hmm. So the common sense part won't come out, but there are some part that's common sense that not like this type.
So
Yeah.
it's not as confusing. Thank
Not
you.
as confusing as this one, yes.
You know, we appreciate you.
Yep. And the multiple choice also won't be like this. Okay, I just want to tell you that. It won't be so confusing. Like, I won't ask for this kind. Is this prediction worthwhile? I won't ask you that kind of questions in the finals. Most in the finals are very straightforward type question.
Okay. Are we going to be having this question with this coordinate thing?
No,
This point of coordinate?
no,
Right.
it won't be. It will be a question that involved with like a data like this.
Okay. All right. Thank you.
Yeah. But unfortunately, you cannot import it. You actually have to enter it manually into StatCrunch. You will see do you guys see my review?
Yes.
Yep, it will be something like my review. Did my review give you coordinates?
No.
No. Did my review give you this silly question down here? Is the prediction worthwhile?
No.
No, it's a silly question. You
Okay,
wouldn't do
so-
that to us.
So you know it's not coming up. Yep. So it's again, look for the reviews, which we're going over right now. So first thing first, I want to point out to you is your final is next Wednesday. It's going to be from 12:30 to 2:30. We don't have a review. We're going to review today. So if you guys, it's recorded, so it's also posted in D2L. So if you guys need to watch it again, please watch it again. So we will spend almost an hour today to review for your finals. You got 2 hours for your finals. Your final is similar to your midterm. You got 10 multiple choice questions and 4 to 5 open-ended questions. It's very similar. And again, concentrate on the open-ended question first because that is the most point. And then the multiple choice, if you are running out of time, you can simply put A, B, C, D on it. Anyone okay here? With your, I think I sent out the review to you guys is it yesterday or 2 days ago, something like that.
Like 2 days ago.
2 days ago in your email. So please do it, check it. And I also send you a key, right? So try your best not to look at your key. Try to do this. These are review finals that I sent to you. And also it's in D2L. So if you cannot find it, you can go to D2L. So before I continue with this review of your finals, this is something I really, really want you guys to know. So I'm not going to talk about chapter 10 because chapter 10, you are still fresh. You still, you still got what's going on. So I'm going to talk about chapter 7, 8, and 9. So this is mostly the kind of like a cheat sheet for 7, 8, and 9. 10, we just did it, so I think it's still fresh. So so if you doesn't have, remember you allowed to have one piece of cheat sheet in your test, front page, not the back page. Remember that. So if you haven't had it done yet or something else, so this will be the cheat sheet that I will really suggest. And again, this is only for 7, 8, 9. 10 is not in here. So I cut this cheat sheet. I do it like diagonally like this instead of this. I do it not diagonally, horizontally. So I'm going to write this as proportion, and this is mean. Okay. Proportion is for categorical variables. It has percent. In a question, you will have the word percentage or sometimes decimals. Those are the keywords you're looking for, and the word proportion for sure. Mean is for quantitative variables, and the big keyword here is mean. So looking for these keywords, and then I'm gonna cut this into half. Okay. Now, we're gonna do different colors so you can see. So this is not different color. Yep. This is for one sample. And this is for 2 samples. So one sample in this case means is from chapter 7, 8. And 2 sample in this case means from chapter 9. You guys following? Okay. One sample in this case, you can do confidence interval, or we can do hypothesis testing. I just short form this to HT and CI. When you do confidence interval, for proportion case, you have to go to your StatCrunch. It's always stat. You go under proportion stat one sample. So you will go to proportion stats, one sample with statistic. I just put stats. So you have to go to this stat, proportion stat, one sample with summary, summary, they call it summary here. I just put summary. Okay. Same thing happens to your hypothesis test. So actually, if you are doing proportion with one sample, this is what you have to do in your StatCrunch. Okay. The only difference here is that if you go to this, there are, oh my God, where was that? Sorry. You will have this, and that's where the perform is. So if you do this, means you're performing hypothesis testing. If you do this, you're doing confidence interval. If you do your confidence interval, usually you will get the low and the upper. Do you guys still remember how you find your margin of error? And how you interpret this? Do you guys know how to find your margin of error?
Somewhat.
Upper minus lower. divided by 2, right?
Oh, okay.
This is how you find your E, which is called a margin of error. Do you guys know how to interpret a confidence interval for this case? We are percent confident
Oh, yeah.
that the interval between this and this capture the true value of the population proportion. So this is how you interpret your confidence interval, and that's how you figure out your confidence interval using your StatCrunch. That's how you figure out your margin of error. So this is for one sample proportion. Now, if you are doing hypothesis testing, then you have to go through, oops, I forgot your requirements. Does anyone know what is the requirement you have to check here? One, it is simple random sample. Always, no matter all this, always simple random sample. That's the first one. So if you want 2, it has to be binomial. That means you have to go through a binomial distribution. Binomial distribution have 4 things: sample size, n. You need to know your n. It has to be 2. Binomial is 2 outcomes. It has to be independence, and all the probability is the same for each trial. And then the third one is your success has to be greater than or equal to 5. Your failure is also greater than or equal to 5. So that means that if you're talking about Republican and Democrat, means we need to have at least 5 Republican and we need to have at least 5 Democrat. Same thing with male and female, at least 5 male, at least 5 female. That is your 3 requirements here for proportion. Okay. And your hypothesis testing is P. P equals to a number, and this number is always this number is called a claim value. So you have to read it from the claim statement. And for your alternative, it's either less than, greater than, and not equals to. Okay. And then do you guys remember how you do your hypothesis testing? If your p-value is less than alpha, what do you say? Or less than or equals. Do we reject or fail to reject? We will reject H0, right? If your p-value is greater than alpha, we will fail to reject H0. I just short form it. Do you guys still remember your conclusion? How many conclusions we have here?
There's 4 different ones.
4 different ones, right? So make sure you go through the 4 different conclusions. There are 4 of them. You can find this in chapter 8. And usually, what do I always say when you reject H0? There is or there is not sufficient. There is sufficient. And if you fail to reject, there is not sufficient. It's always like that. And then in order for you to figure out either you use warrant rejection or not, it depends on your claim. If your claim statements has equal sign, then you have to use the what? The word rejection. Warrant rejection. And what happens if your claim statement is either less than or greater than or not equal? Then you will use support. You don't use the word reject. You can say support or conclude. So make sure you guys know the 4 ways to do this. It depends on your claim statement. Where is it at? Is that at H0 where you have equal sign, or is that at H1, which is less than, greater than, or not equal to? And it depends also on the p-value, either less than or greater than alpha. Either you reject or fail to reject. So make sure you guys know how to do this. This is very, very important. Don't forget, the claim statement is always given in the question. So I got my my previous class, I got students make their own claim statement. That means that yep, don't laugh, because I have people do that before. That means that this is like here, they should have a claim statement, right?
Are you supposed to underline the claim statement? That's what you told us.
Yeah, we do that, and then you just put it there, right? And a lot of students don't listen to me, and they just make their own claim statement, and boy, oh boy, you will get 1 point off immediately, because make sure you copy down the claim statement as written on the question. Don't create your own claim statement. You guys got me? You're making your own question here. Then this is for proportion. And then now we go for mean. And again, this is for 1 sample. And this is for 2 samples. Okay, so we kind of break it down to. So when you read the question, first thing you first do is figure out, is that proportion or is that mean? And then once you figure out, you ask yourself, is this a 1 sample or is that a 2 samples? Then you kind of know which rectangle or which part you are concentrating on. And then you ask yourself, is this a confidence interval or is this a hypothesis testing? You know, because you break it into 2. So this one, for mean here, you also have the same thing. I'm going to use a different color. You can do a confidence interval, and you can also do a hypothesis testing. But no matter what you do here, oh, by the way, in your test, I will ask for sampling distribution. What is a sampling distribution if it's proportion? It's gonna be,
if its proportion is
Z.
Z.
It'll be Z.
Yeah.
Doesn't matter if it's a 1 sample or 2 samples. I don't care how many samples you have, 10 samples, it's still gonna be Z. But for mean, sampling distribution will be what? T. Okay, so we only got Z or T in this case. We don't do anything else. And also in your test, this is very important, guys. I will also ask you for a StatCrunch command. What is a StatCrunch command? This one. This is the StatCrunch command that I'm asking for. That means in your test, you have to tell me, I asked you for StatCrunch, you have to give to me what you did in StatCrunch. Means if you go to your StatCrunch here, right, you did what? You did stat, you did what? This, and this, that, you know what I'm saying? So you have to follow, just tell me what you did. So you just write it down. Like here, prop stats, 1 sample. So for a confidence interval, you have to do a T distribution. A T, not T distribution, just T. In your StatCrunch is T stat. Well, let's go stat now. T stats, and then 1 sample either with data or summary. So in this case, this is T stats, 1 sample either with data or summary. So this is what we call as your StatCrunch command. And yes, this sampling distribution worth 1 point in your finals, and the StatCrunch command also worth 1 point. It's a very easy 2 points here. Then in your StatCrunch, they will provide you the lower and upper. And if you want to find E, it's the same thing. You take the upper minus lower divided by 2. And if you want to interpret this, it's the same interpretation that you guys did over here. Same.
Do we have to interpret it for the test?
Oh, yes. And instead of using population proportion, this will be using population mean. So the only difference here is we don't use population proportion for this case. This is a population. Oh yes, Linda, you have to know need to know how to interpret this. You guys all right? This is the whole summary that I'm doing here. Now, if you want to do a hypothesis testing, it's going to be the same thing, H0 and H1. And yes, I will post this in D2L. So if you doesn't have time to copy this, or I will post this whole thing in this document in D2L. Instead of using P is for proportion. Now it's mean, so we use mu. So this is mu equals to a number, and then less than, greater than, and not equals to. And the same thing, some of you asked me, is this claim is the same as this claim, doing the p-value less than? Yes. I want to tell you the whole chapter 7, 8, 9, we are using exactly the same thing. The same conclusion, the same decision format. So we don't change it. Okay. But the requirements are a little bit different from the proportion. The first requirement is still simple random sample.
I have a
But
question real quick.
Mhm.
For H0 or HO on the first one, you put equal to next to mu and not equal to. But HO isn't it always equal?
Yeah, HO is equal. This is number. This is a number. So this is a number.
Okay,
This is a number.
I see.
Yep, this is a number. Again, this
But
is
that's
a
always
number.
0, right? I mean,
No, it's not 0. No, this number is based on the claim statement.
okay.
For example, if you look at your the review for the exam, they will ask you for 38%. They will ask you for let's say there is a less than 26. So this is less than 26 years. So this 26 is that number we're talking about here. And
Okay.
usually is in your claim statement. Usually is in your claim statement. And yes, so I just want to point out to you that this number that we have here, I hate to draw a lot of lines. It's going to be in the claim state. It's a claim value. And when I say claim value, means it belongs to the claim statement.
You said on the test you will let us know if it's less than or greater
Oh, yeah.
than in the claim
Yeah, it'll be
statement.
something like this. You just need to look for it. Like this, yeah, this is less. I'm not gonna be bold or underline the claim statement. You have to read the claims, the question. Yep. The requirement for this is simple random sample, and the second requirement is your population is normally distributed, or your sample size is large. But this is called loose requirement. So if you have a sample size that is small, then make sure that there is no outliers. That's the only thing that they're asking for. That if you got a small sample size, like 5 or 8 or 10 or 15, 20 people, then make sure that this 20 people is not an outlier. You guys okay here? You will see some examples coming up. Yep. So this is all for mean, one sample. This is all for one sample. So to point out to you, one sample, one sample. Now we're gonna do with 2 samples. Now when you do 2 samples is different, okay? So again, in 2 samples, we will be doing also a confidence interval. So no matter what you do, you have 2 types, either confidence interval or hypothesis testing. So this one is very similar to the StatCrunch is very similar. It's where you go to PropStat. But instead of doing 1 sample, you just need to select 2 samples. And then summary. Okay. And again, the hypothesis test is the same thing. You just need to perform a different skills. So when you guys do the confidence interval, this is, I put a big star on here because this is the one a lot of students get wrong. If you get one till test, what is the confidence level you use? One minus 2 alpha or 1 minus alpha if it's a one till test?
1 minus alpha.
2
2, 1.
alpha.
Minus alpha.
Again, class, if you get this wrong, your whole confidence interval will be wrong. Don't laugh, because in the finals, when you make your test, I'll be the one that laugh if you get it wrong. Which one? One till test is 1 minus.
1 minus 2 alpha.
Yes. Is that
Where is
Rachel?
it?
And 1 minus alpha. I thought you guys have written this on your paper.
We don't have the sheet yet.
Oh, okay. So this is how you this is, don't forget this, I put a star here because it's very important, because a lot of students mix these two up. Now you got this little thing I did. Again, this is only 7, 8, 9, so 10 is on your own if you use this piece.
Is that the table on the 8.2
No,
notes or something?
no,
Oh.
that is critical value.
Oh.
Now, how do you interpret this kind of this confidence interval? Are we using we are 90% confident? Are we using this interpretation? We are 90% that, 95% confident that, are we using this? No, we don't use this interpretation like what we did in the one sample. The interpretation is either if your confidence interval is minus plus, means what? It captures 0, right? Remember this one?
Oh, is it significant or not?
So is this
Yeah.
significant difference or no significant difference? If this is how you interpret this kind of confidence, it's different from that one. So
Oh,
that is no significant difference, right?
no significant difference.
And it means that P1 in this case is equal to P2. That means these two are the same. Do you guys remember what happens is both of these are negative?
There is a significant difference.
So it is significant difference.
It's less than.
Yep. And P1 is less than P2. And if both of these is positive,
Significant difference, and then it's greater than.
Yep. Good. So this is how you interpret this confidence interval, and we don't interpret with VR 90%. No. If you do that, you get it wrong. Okay.
So how do we know which one to use again? I forgot.
Depends on your confidence interval. I do not know.
I mean, in terms of like, how do we know on the question which one we are going to need?
Using this,
Are we going to interpret the top or the bottom? Like, how do we know that again?
depends on your confidence interval. Do you mean which one to pick among these three?
Yeah, so like if the question,
It depends
What
on the
is-
result of your R. I do not know what your R result came out. You know what I'm talking about here?
okay,
Because
Yeah.
I think it's our upper and lower values.
yeah, because you have, if you go on here and if you type numbers here, and let's say you do 95. This one shows one negative, one positive. That means you're doing the first one.
For the question, like if it's a word question, how
It's
do
all
we
just
know
questions.
there's no word
They're all word
question?
questions.
Oh no, I mean, sorry.
Okay, first thing first, let me answer Cecilia questions. How do we know this? It depends on your stat crunch, whatever you came out in here. You got it, Cecilia?
Oh, no, yes and no. Just I'm asking, how do we know if we need to respond? We are 95% confident,
When
or
you have
there's
the
the interpretation.
you have one sample proportion or one sample mean.
Oh,
You
I
see what I'm reading? I'm writing down here on this paper. The one on top.
Yeah, so the
they are
two
for one
samples.
This is
Okay.
2 samples now, so it's not the same as 1 sample. Yep. Okay,
Okay, that
Linda,
makes
what's
sense.
your question now?
For the word question, how would we know if it's a two-tailed test or a one-tailed test?
It depends on your question.
Okay.
If I give you this question, number 5, is that 1-tailed test or 2-tailed test?
Less than 1 tail.
Yes. When you got 2 tails, when is 1 tail and what is 1-tailed test? You should know this. When you have
Greater
what?
than or less than.
Very good. 2-tailed test?
Greater
Equal
than
to or
Equal to?
Same.
The
Or
same, yes,
not.
good. Same, equal to, yes. These are 2-tailed tests. Hello, you should know this. So for hypothesis testing, we will still using P, but it's going to be P1 and P2. So this is P1 equals to P2. And then P1 is less than, greater than, or not equals to P2. Okay, again, this is one sample. This is 1-tailed test. And this is 2-tailed test. You got it, Linda?
Yes.
So this is same thing with, I don't care if it's 1 sample proportion or 1 sample mean or 2 samples mean or 2 sample. If you got less than or greater than, it's always 1-tailed test. If you have not equal to, equal and not equal to, it's always 2-tailed test. Okay. What is the requirement? The requirement is exactly the same as the one that you see here. That means it has to be a simple random sample. It has to be at least 5 success and 5 failures. And you do not need to check for binomial in this case. So if you want to put binomial, it's fine. So the third one is binomial, and this one is again loose. So you don't have to worry about that one. So I can tell you that if you know your requirement for the 1 sample proportion, you will use the same requirement for the 2 sample proportion. You guys got what I'm saying here? So what is going on is they are the same requirements, no matter it's 1 or 2 samples, but make sure it's proportion. And we will still use the same decision, and we will still use the same conclusion when you do your hypothesis testing. They're all the same. And what happened is, this is special. I think you guys know what happens when you do 2 samples. Your conclusion from your hypothesis should what? Should match. Should be the same as the conclusion as the hypothesis testing. Confidence interval. So if a confidence interval says that P1 is less than P2, then your conclusion will also say P1 is less than P2. They all, they all will agree to each other. And this is what happens when you do 2 sample tests here. You guys all right here? Questions? Right, next, mean. Now this mean is mean, very mean. Actually, we have to split this mean into 2. Because for this is all mean. Okay, this is for independent case, and this is for dependent case. Or we call it matched pair. You guys know what's the difference between these two?
Yeah.
Independent means these 2 groups are completely not related to each other, like female, and I break you guys to male and female, or break into age group. One is older and one is younger group. That is called independent. And dependent on match pair usually is for before and after, you know, where you do your like before diet, you weight yourself, and then after diet, you weight yourself. That is called dependent. Match pair means is relationship like father and son, like mother and father and wife, father and mom, you know, sisters and brothers, you know, that relationship. So if you want to figure out, you know, if your father and mother, you know, how old they are when they get married, you know, those are the things, you know, this match pair. So we get all this like 50 people, 50 couples. You guys all right here? So make sure you guys know this because there are two different things. So again, for independent, we have a confidence interval and we also have hypothesis testing. The same thing. We will be using exactly the same StatCrunch, which is T-stats. Instead of one sample, this is two sample. And then you either do data or you do summary, either one of those. Okay. And we will use back the same thing here. Everything I draw in blue, same.
For the significance level, when do we know that we should double it?
When you have one tilde-test, is that what you're asking for?
I think.
Can you wait for that one? I know what you're asking for. Okay, let me finish this and then we'll talk about that one. So, so it's gonna be the same. So what happened is these two are gonna be the same. That means that one tilde-test, two tilde-test, confidence level is 1 minus 2 alpha, 1 minus alpha. Interpretation is the same interpretation. The hypothesis testing is the same. Instead of using P1 and P2, it's going to be mu1 and mu2. And again, one tilde-test is less than or greater than, two tilde-test is, not equal to. For the condition, for the requirements, the requirement is exactly the same as the requirement that you see on your mean. So this requirement is the same. Same requirement. That means that simple random sample and population is normally distributed or sample size is more than 30. If you have small sample, make sure you have no outliers in this case. Okay. Again, the conclusion is always match. So these two conclusions will always match. So it's just a duplicate of what we just did on this proportion, but this is for mean. This is a duplication of it. Okay? Mostly everything is the same in this case. However, when you do the match pair, the one with this, the confidence interval in this case is going to be stat, two samples, not two samples, pair, we call it pair, sorry. Stats, T-stats, sorry, forget about T-stats. T-stats, this also has a T in there. And then pair, you got one in pair, called pair. Now, it also have, so when you do this, you're still following the confidence intervals. That means you're still following the one tail is 1 minus 2 alpha and 1 minus alpha, the same thing. But the only difference here is the interpretation. Your interpretation is no longer capture zero, no difference, significant difference, all this, no. The interpretation for the match pair is we are % confident. You know, the same thing as what we did in the one sample one, you know, that the capture the true value of the, this one, we're going to change it to population mean difference. So this is just population mean, right? Remember last time we did this one, we call this as the same interpretation, but we use population mean. This is population mean difference. So I just want to point out to you guys that when you guys, how do we differentiate between these two is we use some keywords. If you want to do the two sample with a mean that is independent one, we use the mean, no, sorry, it used the difference. This is the keyword to use. Difference between mean of the male and mean of the female. Let's say if you do male and female. This one, if we use the word mean difference between father and mother, if we're doing, you know, father, because father and mother is a match pair. So the key word here is the difference between mean, and this is for independent case. And then if you have the word mean difference, it is a match pair or a dependent case. So make sure you read these keywords. Those are the keywords that I'm teaching you here so that you don't get wrong. And then your hypothesis testing, you are not doing mu1 equals to mu2 and mu1 is greater than or not equals to or something else. You're going to do mu d is equals to 0 and mu d is less than, greater than, or not equals to 0. And yes, this is always 0. Some of you are asking me, is this always 0? The answer is yes, this is always 0. And this is mu d. So you can kind of figure out a little bit difference on both of this, on this. So this is the conclusions of what we're going to do here. And it's a lot of work. I didn't say this is easy. Okay. And then, Linda was asking for critical value. So when you do critical value, so since this is a Z, so if you want to find a critical value for this fellow, no matter it's I don't care, it's a 1 sample or 2 sample, I have no room, so I'm going to put it right here. So the critical value in this case, you have to use normal calculator. Okay, in your StatCrunch, you use normal calculator. And same thing happens with mean. I don't care it's a 1 sample or 2 sample. I don't care it's independent, dependent. If you want to find a critical value, you have to use the T calculator. And it's all depends on either it's 1 tail or 2 tail. If it's a less than, then you make sure you use the less than symbol. If it's a greater than, then make sure you use a greater than symbol. If it's a 2-tail test, make sure you double your critical value. So make sure you find your 1-tail or 2-tail, and then you double it. Same thing happens to your mean. I don't care if it's a 1 sample, 2 independent. If you have a less than, then you make sure you use less than symbol. If you have a greater than, make sure you use greater than symbol. If you have a 2-tail test, make sure you double your critical value. I will show it to you all this. Yeah, it's in the review. So this whole thing that we did here is kind of like a conclusion of chapter 7, 8, and 9. So yes, this is pretty much important. And please, I would recommend you to write down some. You just say, oh, I'm lazy. David posts this in D2L, so I just print it off. I would recommend you to write this down so that you at least memorizing this, you know, once you write it down. And at least it's more organized. This is so, you know, all the way around here. So now I'm going to teach you how to use this table if I give you a question. For example, read question 8. No, not 8, 9. Let's read question 9. This is question 9. So I don't want to underline. I don't like my. No underline. I don't know why I don't underline it. Read question 9. I don't know why it's. All right, read question 9. So first thing you ask yourself, is this question 9 is talking about proportion or mean? Anyone? Proportion or mean?
Proportion.
Why you say proportion?
Because of I'm not sure. The
I think
occupant.
it's mean.
Oh,
As I say, if it's proportion, it has to be categorical variable, percentage or decimals. Mean, it has to be quantitative. It has the word mean on it. So which one is this one is? Number 9. Do you see any word mean on this one? No.
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 No. How about 10? If you read question 10, do you see, is that proportion of
Yeah,
mean on number
It's
10?
mean.
You can tell the difference now, right? Because
Yeah,
usually
it says
when
mean.
when I ask you for mean, the word mean should be there, right?
Mhm.
Yes.
You see that? Okay. So yes, this is proportion. The question 9 is proportion. The reason why is because it's categorical, means that either do you wear seatbelts or do you not wear seatbelts? Do you got killed or not? Do the person got killed or the person did not got killed? You know what I'm saying? So it's yes or no type question. So that's why it's categorical. So this is proportion. Now, once you know this is proportion, then you talk about, so it's going to be on your left side here. Is that one till or one till? One sample or 2 sample?
2.
2.
So this is 2 sample. Okay, and A is asking you to do what? A hypothesis testing. So when you do hypothesis testing, which is this is proportion, 2 samples. This is what your stat crunch should have to be. Confidence into you have to go to prop stats, 2 samples, summary, and then you have to write, this is your hypothesis statements. These are your requirements in this case. So you only concentrate on the lower left here.
Mhm.
Okay. Can someone tell me what is your claim statement on this question? Where is your claim statement? Usually I underline it. And again, when you get your,
That seatbelts are effective in reducing fatalities.
there you go. This is the one. And what is the big keyword here? What are we testing for? Less than, greater than, or not equal to?
Not equal.
Less
Not
than.
equal to.
Where you see not, do I say not? See, you guys create your own question in your finals now. Do you see the word not equal to?
No.
No. Let me, it's not equals to. You create your own question here.
Less than, because it says reducing.
Very good. Yes, because the word reduce means less than. You are correct. Okay, so that means P1 is equals to P2, and H1 in this case is, you have to read the question. That's why P1 is less than P2. And the reason why you use the less than is because this is reduced. And this is your claim statement here. Oh, yeah. Read the question. Okay. So now you will go to your stat crunch. Where's my stat crunch? There you go. So this is proportion to stats. So you will go to stat, proportion, 2 sample with summary. And what do you need to put in on number of success here?
31.
31. Observation.
And then 2,823.
Number of success on the other one,
16,
and the observation.
7,765.
And we have to do a hypothesis test. Make sure you change this to become less than. Okay. And by the way, before I continue doing all, I think you guys know what to do with this one. What is your sampling distribution in this case? Because this is worth a point in your test.
B.
T.
T or Z?
Z.
Z.
It's Z because proportion is always Z.
Yeah.
And I asked you for stat crunch. What do you type down for stat crunch?
Stats.
Stats.
Proportion stats, two samples.
Proportion.
Very good.
Sample.
Proportion stats. To sample
With data.
with summary.
I mean, with some.
I know you won't, you can't figure out. So this is your, guess what? Sample distribution, 1 point. Stats crunch, another point. You with me?
Mhm.
This is still A. I didn't finish A yet. This is still, we are doing A here. Okay. So once you type this, we can find out what is your test statistic. Now, if you do not know we are using T or Z, you can tell by looking at your test statistic. What do you see in your test statistic here? What letter,
Z.
T or Z?
Z.
A Z. So we know it's going to be Z. And if you do mean, it's going to be T stat here. And the test statistic in this case is 6.106. And your p-value in this case is what? Exactly
1.
1. Yep. This is that. And you just need to double check. Yep, P1 is equal to P2. P1 is less than P2, which is what we have, the word reducing. You guys are with me here?
Mm-hmm.
Yeah, I have one question real quick. How is it that we know which one is P1 and P2 again for this
Usually
example?
the first one is, oh, very good. Oh, this one is wrong, actually. You're very good questions, Cecilia, because I didn't. We want seatbelts to reduce fatalities means P1 in this case should be what? Thank you for reminding. Yep, P1 in this case should be what?
Greater than.
Yes, that is correct. So that's why this is all wrong already. So yep, because at the end,
Okay.
thank you for doing that. So if you got 2 samples, those case proportional mean, make sure you tell me what is P1 and P2 is. Since you want it to be reducing, means that P1 here has to be what? Those who wear seatbelts or those who do not wear seatbelts?
Where?
Wear. Yep. And P2 is those who not wearing, right? Then this will be actually is greater than. Then we will figure out seatbelts is actually is reducing. You guys all right here? So now we need to do something with this because we got these 2 what? Switched around. Yep. So this is what? 16? 7765. So thank you for doing for reminding me that, Cecilia. Yep, that is another so you had to watch out. And now we don't use less, we use greater. So our p-value is still the same, but our z-stat is just changing from positive to negative. So just a little bit change. And alpha in this case is 0.05. So can you make a decision here, anyone? Is this p-value is less than or greater than alpha?
Greater.
So the decision is reject or fail to reject. So the decision is fail to reject, H0. And what is your conclusion in this case?
There is not.
There is not sufficient evidence to reject or to conclude the claim.
To conclude.
Yep, to conclude. Anyone know why we use the word? Anyone know why we use the word conclude, not reject? Because our claim statement is where?
It has a,
In H1, because this is what it means. So once your claim statement is in H1, we use the word conclude. If your claim statement is in H0, we use the word reject. And can someone tell me what is the claim here? Conclude. The claim that,
Plus, seatbelts are effective in reducing fatalities.
yes, seatbelts. Am I doing this right? Should be wrong though. Seatbelts should be sufficient evidence.
Yeah. I'm a
Something
little
is wrong. Let me
confused.
double check. That's why once I look at it, it's like, something is wrong here. Usually seatbelts, if you do this, means that seatbelts are not safe. Which is like, huh? So 16 P1, you want reduce fatality. Oh, yep, this one is actually less than. Sorry.
Oh, okay.
Because
So,
yep, this is less than in this case. Because you are seat belts, that means people who have died in seat belts actually is less than people who don't wear seat belts, means they are reduced.
oh, yeah.
Yep, so actually I have to change it. So one little sign like this, yep, the whole thing changed.
Mm,
The z-stat still same, but your p-value is actually different now. So your p-value in this case is not, is 0, right? It's less than that, means it's 0.
mhm.
So this is actually 0 plus. Sorry about that. No. See, again, as what Cecilia mentioned, do we need to use common sense? I will say a little bit. So once, that's the reason why when I get into that, I was like, the conclusion, I was like, that conclusion sounds weird. We know using common sense, the seatbelts do, you know, to save life, you know what I mean?
Okay.
So that's what, again, class, that's what I mentioned a little bit when system means common sense. I said, yes, just, you know, when you do this kind of work, just use a little bit of common sense. You know, seatbelts are effective, you know. And if you find out that your test here says seatbelt is not effective, something is wrong. So just recheck it again. You guys all with me here when I talk about common sense? Now, next thing we still in, this is what we did here is just for A. We didn't do anything for B yet. So now we're gonna do part B. Anyone know how to do part B? Do the question provide us confidence level? Nope.
No.
So can someone tell me how you find the confidence level for part B?
If it's less than or equal, or I mean,
1 minus 2 alpha or 1
yeah.
minus alpha?
1 minus
2A.
2A, right? 2 alpha, right? Oh, by the way, I'm going to take attendance, so please do your you guys know attendance. And alpha in this case is 5%, 0.05. So how much? What is this? Is anyone know? What is 1 minus that? 2 alpha. Alpha is 5%.
0.9.
0.9, 90%, right? So what you do here is you just need to use your option and then go to edit, and then you go to confidence level, and then you change to 90%, and then this is your answer here. So you guys, this is your answer, right? This is the, you know how to do it. So this is the answer. So make sure you give me that number. Do you need to show me this in your test? Conf level is 90%.
Yeah.
Yes, because that's how I know. And if I know you didn't get the right answer, means you use a wrong confidence level. And usually I don't ask you this question, so don't worry about this question C. Question C, I will ask you to interpret. So question C, I will ask you to interpret the confidence interval. So does anyone know how to interpret the confidence interval here? If you remember, are we using VR 95 or 90%, or by using the plus minus one?
Plus minus.
plus minus. So since these two are both what, negative or both positive? Oh, this is the wrong one, sorry. Where was my mouse? Where is my mouse?
Both negative.
So you find out both of these are negative. So what can you conclude?
There's a significant difference.
There is a significant difference, and what P1 is
Less than.
less than P2, right? So what is going on in here, in your here? So since your confidence interval in this case is both negative, right? I'm just so how do we interpret this is this is for part C. Since both of these is negative, there is significant difference, and P1 is less than P2. Is that what the conclusion in part A when you do hypothesis? Are they matched? Because the conclusion says that P1 is less than P2 here.
Yes.
So that means that which match with the conclusion in part A. So I think you guys know, right? The two of this is always match, always the same. So if you find out one is P1 says P2, the other one is P1 is greater than P2, or P1 is equal to P2, something is wrong with this, with your test. Something with A or B, one of them is wrong. You guys okay here?
Yeah, so far.
So far, yeah. So
So
let's
it's easier when you're talking us through it.
Yep. So that's why I want you guys to do this and see what you guys think. Let's take a look at number 8. Read number 8. I'm going to use a
So
different.
that's the mean,
Talking about the mean.
one sample.
One
So
sample.
you see, you guys pick very quick. I mean, again, reading is part of the thing. This is talking about mean, and this is talking about one sample. Yes, because there's a lot of mean came out, and you only got picking one the variable, which is the systolic blood pressure. So so when you look at this table that you see here, which one do we concentrate on? The top left, the top right, the
Top right.
bottom, top right. So this is what we do. And are we doing confidence interval, hypothesis, or testing, or both?
Confidence.
Did you see the word confidence interval in there?
No.
Oh, no, I don't, sorry.
So this is fine, don't worry about that. This is how you learn. And Cecilia, don't worry about that. This is how you learn this. So in the test, so this is actually is what? Just performing what?
Hypothesis test.
Hypothesis
Hypothesis
testing, and the
test.
claim is right over here, right? Somewhere over here. You guys all right here?
Yeah, so for when it's asking for confidence interval, it's gonna actually say that.
Yep, you will say the word confidence interval.
Oh, okay.
See that?
Okay,
Very. Is it going to be the same in your final class?
Yeah.
Yes. So you're looking for, again, that's why reading is a part of this. Really, I mean, I really recommend you to print out the test so you can do all this. If you have a color pencil or color pens, you know, like me, drawing lines so you can see it, you know what I'm saying? And you got lots of room, so you do not need to, I give you a whole page blank, so you got lots of room to do the work. And if you just do it on the computer like here, then you might have to do like me, underline with different colors. It might take some time, you know what I'm saying? Just want to point out to you guys that. Okay, so what is the sampling distribution in this case?
T.
T.
It's a T. And what is the stat crunch I'm asking you to do?
T stats, one sample with summary.
Oh, you are good. So it's T stat, one sample with summary. Not summary here. Is with
Oh, with
data. Why this is with data is because they want you to use what?
Body
Mm.
data.
Body type. And if it's summary, I will give you like all these numbers. this how many people and this how many people, I will tell you. But since I didn't tell you the sum, the how many people and stuff like that. So how do you do this in this class is body data is the file name. So you have to go under StatCrunch. Where is my StatCrunch data?
So, question for you. Because the last time that I did it, it didn't upload into StatCrunch for me. But do you had it linked in
Right here, Teresa.
okay.
So you go to the homework, click on StatCrunch. Do you see the data set from your textbook?
Yeah.
So click on it. And we are looking for what? Body data.
Body data.
So there is the first one. Click on it. And you got lots of them, but we concentrate on this one. Only one. We only concentrate on one of this. We only concentrate on what? Systolic
Blood pressure level.
blood pressure. So one of them is systolic blood pressure, which is what? This fellow. Okay, so you go to stat, T-stat, one sample with data, and you are clicking on systolic. That's what we are doing. You guys okay here? We are performing hypothesis testing. What do we performing here? Is equal to 120.
Oh yeah.
So what do
So
you
equal
need?
to and not equal to.
So, oops, sorry, wrong one. I'm gonna X this one up. Got a lot of windows pop up here. So you're gonna do hypothesis testing equal to not 0. This is 120. Okay, this is the hypothesis testing you have. Because it's one sample, you don't do mu1, mu2, and something else, or mu-d. And again, I think the rest you know what to do, right? This is a T. So again, that's what T come out. Last time we used a Z. This is a T. That's why, and then the p-value. The rest, I think I know. Do this question wants you to perform confidence interval, class?
No.
No.
Okay.
If you do your confidence interval, you are wasting your time. You don't get any extra credit. You waste your time. You guys okay here with me?
Yeah.
Practice. Now, again, the key is here. Now, because the time is almost up, we're going to do the last two questions. This last two question is coming out in your multiple choice question. The rest up here is open-ended one, mostly. This is a multiple choice question. So let's talk about question 13A. So you need to find what we call as the critical value. This question wants us to find the critical value. And so how do we know it's Z alpha, T alpha, or neither? So please pay attention here. Again, this is in your multiple choice. In order for you to figure out if they are neither, we do the neither first. You only do one, not all three. One, either that, or that one. Okay. Neither, it means that it is your population is not normally distributed, means it's skewed, and the sample size is small. It's less than or equal to 30. In this case, called small. If you want to do Z alpha over 2, sigma is given. You guys know what sigma is? Can you tell me which one of ABC sigma is, which one is sigma is given? Anyone? A, B, or C?
What was the question?
Which one is a sigma symbol? You found in A,
C.
B, or C? Yes, C. That's 6. That looks like number 6. It looks like number 6. Okay, this one. Not him, but this one. So can you tell, and if you want to use T, you use when S is given. That means these two are, this is going to be T. So out of these 3 distribution, let's read the first one. N is 9, S is 15, population is normal. Is this neither?
No.
No, because population is normally distributed. It's not neither. So is this T or Z alpha over 2?
E.
because S is given. So in this question, this is T alpha over 2. Now you need to find what is this value is. And how do you find this value is you have to use T calculator. So when you go here, you go to stat, go to calculator, go to T. Okay, minimize this. I don't care about the numbers behind, I just care about the graph. So it says that we need degree of freedom. Does anyone know how to figure out the degree of freedom for question A?
10 minus 1.
Which is 9 minus 1, which is
Yeah,
8.
8.
So this is 8. Okay. And this one, we don't care if it's less than or greater than, so we just leave it there. And what is my alpha in this case? If I'm asking you to find 95% confidence level.
0.05.
Yep. And what you need to do here, do you see all this over 2? You see all this over 2. So you have to take the alpha and do what with it? Divided by 2. So what you need to do here is you just take alpha divided by 2. And that is your answer in this case. So your answer can be plus or minus, doesn't matter. So your answer in this case, because it's a two-tailed test, remember when you have alpha over 2, it means you got two-sided. So your answer in this case is plus minus 2.306. You guys got it? Okay. Make sure you use O. Next we have is B. Is this neither?
Yeah, it's neither.
This is neither. Because your sample size is small and your probability is skewed. If you say neither, do you need to find Z or T?
No.
No, that's it. Okay. How about C? Is that neither or neither?
No, that's Z.
This is Z because sigma is given to us. So you need to find Z alpha over 2. And how do you find Z alpha over 2 is you don't use T calculator. We use normal calculator. Yep. So go to calculators, go to normal. The mean and sedition is always 0, 1. They don't ask for degree of freedom. You just need to take this and divide it by 2. Your alpha divided by 2. And your answer is again plus minus 1.96. So you always have alpha over 2 because this is alpha. So plus minus 1.96. So this is how you figure out your question 13. Now question 14 is asking for p-value. Now p-value is a little bit different from critical value. What's the difference is, remember last time when we do critical value, we put alpha over 2 here. So this, what you're finding here is your p-value. So this 2.3 or 1.9 that you figure out earlier on is your p-value. So now, in order for us to find the p-value, you just do the opposite. So what happens in this case is we got mu here. If you use mu, is that a T or a Z?
T.
T. Mu means mean, right?
Yes.
And if you remember mean, the sampling distribution is always T. So that means you have to use T calculator in this case. So we cannot use this because this is normal. So we have to go to T calculator. And usually we have a degree of freedom. So we have a sample size of 38. So what is a degree of freedom?
37.
37. Now, if you look at this test statistic, it's negative 1.45. This is where you put him here. Last time you put alpha over 2 on this probability. Now you have to put this negative 1.45. If it's a negative, you use less than. If this is a positive, you will use greater than. And you hit compute. So this is your p-value here. So your p-value in this case is not 0.0. So your p-value here is 0.0777. This is wrong because this is, if you look at the graph, this graph only have one tail. Is this one tail or two tail test?
1, 2,
With a not equal sign. So this is actually is a
2 tail.
two tail, but your graph here show one tail. So that means the other tail should be exactly the same duplicate of this below. So what you need to do with this p-value is you have to double it. Okay, and whatever you know how to use a calculator, that will be your answer here. If this is less than, then your answer is just 0.0777. Okay, but if it's not equal to, it's a two tail, you have to double it. You guys all right here? How we do question number 14?
Yes, and you said that these are gonna be multiple choice.
Yes, this will be multiple choice.
Okay.
Yep. This, and I only count one question on 13. I don't do ABC so many. I just do one question here and then one question on 14. And the rest of it is mostly open-ended questions. So, and I think I sent you guys a key, right? For this review. And try your best not to look at the key. You guys with me here? Because once you look at the key, that means that you use your cheat button, and in your test, there is no key. Okay? So try your best to do this on your own, and then once you finish, you can refer to your key for your answers. If you get it wrong, try again. If you get it right, good for you. That's correct. If you got question like number 4 and number 11 in your test, you have to do what with these numbers? You
Enter
have
them
to
manually.
enter them manually into StatCrunch. There's no import. And if you enter one wrong number, it's not your cell phone. It does not auto-correct it. So you will get everything wrong. So if you, like number 4 and number 11, if you get them wrong, please check your data. Okay, if everything's entered correctly. So make sure you guys do this. It's very important. Anyone have any questions for me before we end today's Zoom class? And yes, I will be posted the cheat sheet that you guys mentioned here. Again, this is only good for what chapter?
7, 8, 9.
9. So 10 is on your own. I think 10, if you guys start, is 10, you guys still fresh. So 7, 8, 9 is the only one. So if you guys want to, you can always rewrite it maybe into half a page, and then you can squeeze more in the other half a page. You guys good? I will post this. I will save this. Let me save this first before I. So I will post it, and then I will say, oh, I did it off. I'm going to say this as 7, 8, 9 cheat sheet. So you know what to do with it. I'll post this in D2L so you guys get it.
Do we have to graph the
Nope. The scatter plot? No.
No, like if it's a two tail or one
Nope.
tail, like do you have
No, you do not need to graph this,
to? Okay.
and you do not need to graph the scatter plot. Remember, we did early on, we did a scatter plot type
Yeah.
with all the dots. You do not
Yeah.
need to do it
Okay.
because it's a lot of work. So no graphing in this final. It's just mostly this is really tough. So I don't want to give you more difficult stuff.
So are there chapter 10 questions in the review, or you said it's just
Yes,
on our
chapter
own?
10 is in the review. Yes, it's
Oh,
inside here. I think it's the last question. This is the one that is chapter 10.
Okay.
This one, the last one. And as you know that the review is very nicely done, means chapter 7 come first, then chapter 8, and then chapter 9, and then chapter 10. In your finals, it's not going to be 7, 8. It's not going to be, in that order. It's going to be like jumble out everything. Okay, so make sure you guys practice. That's what I want. And if you need help with this, or you're stuck, you doesn't know what to do with it, please make sure you send me an email and we can do a one-on-one Zoom. Just tell me the time. I do have finals on Friday and I do have finals on Tuesday. Just want to tell you that. So if I'm busy, means I haven't finals. That means I cannot do one-on-one Zoom with you. So please give me a list of times, like Thursday these times, Monday this time, so I can set a one-on-one Zoom with you guys. So make sure you guys, if you need help, set me a one-on-one Zoom with it. And
what is your Oh, I would like to set that up. What is your availability for Monday?
Send me an email. You guys send me an email.
Email? Okay.
Yeah, email me. And if you got a group like Cecilia and Teresa, I know you guys put together. If you're in a group, perfect. We just, do one group, together.
Mhm.
You
And-
said you're busy on Tuesday,
I
but
have
are
a-
you still able to?
I got 2 finals on Tuesday I'm giving, so I'm
Okay.
gonna be really busy on Tuesday. So give me a time and I will tell you, I will give you the Zoom link. It's not gonna be the same Zoom link. And the last thing I want to mention is your grades. Your grades in D2L is pretty up to date with all the stuff in all the points in there, your homeworks and everything. So I want you guys to please double check it. And if I make any mistake with it, email me, because if you don't email me, any mistake I make is gonna be, I told you, right? Your online homework, instead of 100, I give you 0 or 1. I forget the zeros. So please check your D2L for your grades and make sure that it is up to the correct grades that I have, because I have a lot of students, so I make mistake too. So I just tell you.
I have a question about grades.
Mm-hmm.
So if I get or if somebody gets like a 89%,
Mm-hmm.
can they still get an A?
Yes. So I want to also,
Okay.
when Sister brought up, if you are in the 9s, you automatically round up to the next grade. So you are 89, you get
And then
9. If you got even 88, if I look at it, and I will say, oh, I know you are. I also mostly 88, 80, the 8s and the 9s are probably round up to the next grade. But those who are in the 7s and
okay.
6 and 5, I probably will not round up to the next grade. You guys got what I'm trying to say? Okay, I'm gonna
Yeah.
end this